All right, our final week before spring break. Let's make it a great one. Challenge questions. Check. How many did you get right? How many did you get wrong? Tomorrow's challenge questions will look a lot like today's challenge questions. So the hope is that if you did not get all three of these boxes today, you learn from your mistakes, and tomorrow you get them right. The challenge question is what we are going to be working on today. Okay. I'm going to cover these challenge questions during our live session at 10:30. So today in mathematics, we are learning about patterns. We're learning about numerical patterns. Two vocabulary words I want to go over really quickly: numerical pattern and something called a term. So what is a numerical pattern? A numerical pattern is numbers, a sequence of numbers that share a relationship, meaning they're not random numbers, but there's some sort of a relationship or a sequence. There's something mathematical going on from number to number. And then the word term, it's very simple. All a term is that actual number. So a number in that group of numbers is just called a term. So let's look at this for example. The numerical pattern, we have a sequence of numbers here and a sequence of numbers here. So this group has its own pattern, and this group has its own pattern. This pattern is different than this pattern. Can you tell me what the pattern is on the top? +1. The pattern is +1 because it's 1, 2, 3, 4, 5, 6. And then the pattern on the bottom is +2. +2. 2, 4, 6, 8, 10. And then you could actually compare the top to the bottom if you want to get very fancy and say the top times 2 equals the bottom, right? But instead of giving it, saying it's the top, let's just give it a fancy name. Let's call the top X and the bottom Y. You could say here that X times 2 equals Y. Does that make sense? Let's look at the third term of both. Is 3 times 2 6? Yes. So all we're doing is we just came up with a letter to represent each. So the top, we're going to represent it with X. The bottom, we are going to represent with Y. And then the relationship is X times 2 is equal to Y. Let's continue. So we are on page 291. Hopefully you have your math book. If you have your math book, open to 291. We are going to work on the odds together, and then the evens. Hopefully we have time during our live session to work on a couple of the evens. So number 1A says write two expressions for the term. And remember what expressions are, right? Expressions are, well, I'll show you an example. Write two expressions that for the term, for the next term, the sixth term, in the pattern 3, 5, 7, 9, 11. So 3, 5, 7, 9, 11. What is the relationship? What's happening here? Well, let's see. Every time it's +2, right? +2, let's make sure. Yep, +2. See, it's the pattern is +2. So what we are going to do, let's see. Let's think of an expression. Ooh, I know. 3 +2, that would be this one. +2, that'd be this one. +2, that'd be this one. +2. And then to get the next one, that'd be this one. It would be one more +2, right? So this is an expression that would help us find this next term. But it says give us two different ones. Okay, then we could also say 3 plus 2, 1, 2, 3, 4, 5 times 5, right? Ms. Stahl, I don't get this, man. That's way too confusing. All right, if you think it's confusing, what if instead of this nasty question right here, I literally just said, find the circle, find the next term. Well, can you tell me that answer? What is it? $13 is correct. So as long as you could tell me that the next term is 13, you are good, my friend. Let's go to the next question. The next question says, write the first 5, so remember, we're doing the odd, so we jump to 3. Write the first 5 terms of a numerical pattern that begins with 1 and then adds 9. Okay. All right, let's get rid of this paper. 1. 1 plus 9 is 10. Plus 9 more is 19. Plus 9 more is 28. Remember, the pattern of adding 9 is plus 10 minus 1. So plus 10 minus 1 would be 38 minus 1, which is 37. So first 5 terms. 1, 2, 3, 4, 5. Okay, we did that. Now it says write an expression to show the 6th term. Okay, so what could we put for the 6th term? Well, once again, we could say, and remember, if you get confused about this, ladies and gents, as long as you can get this answer, then you're good. So right now, if you can get that answer, you're good. The pattern, or the one example of an expression would be 1 plus 9, right? And then now we're here. Plus 9, now we're here. Plus 9, now we're here. Plus 9, now we're here. Plus 9. That would give us that next term. So this is one example of an expression that would give us the missing box. What's another one? What about 1 plus 9 times 1, 2, 3, 4, 5? 1 plus 9 times 5. That makes sense, right? So the real question is, what is that 6th term? What is the 6th term? Did you get 46? If you got 46, you are good, my friend, because that's the next term. Let's move along. What about 5? Let's see what 5 says. 5 says, write the first term of a pattern that begins with 9 and adds 9. All right, let me show off my disgusting mouse writing skills. 9, that one's not bad. 18, that one's not as good. 27, 36, 45. Write the first 5 terms of a pattern that begins with 3 and then adds 3. 3, 6, 9, 12, 15. Circle the corresponding pairs of terms in the patterns. Okay, so first term of both is this, second term's this, third term's this, and remember you should be putting this in your book, fourth term's this, fifth term's this. So now it says, can you tell us how the top compares to the bottom? Sure I can. The top minus 6? Oh no, that doesn't work for all of them. The top divided by 3. 9 divided into 3 is 3. 18 divided by 3 is 6. 27. So let's put that. Let's put top. Oh my goodness. Divided by 3 equals bottom. Now, what some people do is they get fancy schmancy. Instead of calling it the top, let's just give it a name. Let's call it X. And the bottom, let's give it a variable. Let's call it Y. So now you can look very mathematically savvy and put X divided by 3 equals Y. Now that looks like algebra, doesn't it? X divided by 3 equals Y. How did you get X? I just came up with a variable. X and Y's are like the most popular variables that people use. So that's how I came up with it. Now it says, can you do the same thing with how the bottom compares to the top? Sure. The bottom's different. It's 3 times 3 equals, it's bottom times 3 equals top. So instead of looking terrible with my mouse, I'm just going to go like this. Y times 3 equals X. Because the bottom times 3 equals the top. Oops. It says many situations. First of all, today, to make sure that you watch the video, I'm going to say, what did I draw just the most amazing picture of? You're going to say mouse. I mean, sorry, I lied. You're going to say cat. That's a cat. It's a pointy-eared cat. Many situations in your everyday life can be described by numerical patterns. The pattern or the table below shows late fees for an overdue library book. Complete the table. Okie dokie. So 1 day, 15 cents. 2 days, 30 cents. 3 days, 45 cents. 4 days, 60 cents. 5 days, 75 cents. Describe the relationship. Okay, so number of late fees, let's give that a variable. Let's call that N. Late fee, let's call that F. So N times 0.15, right, 15 cents, equals F. Is that the only thing I could have put? No, that's not the only thing you could put. You could put F divided by 15 equals N, right? And you didn't have to give this N. You could have said D right here for days, or L, or P, or T, or anything. It's just a variable. It's whatever you want it to be. But then late fees, you could have, used any variable there as well. But what's important is that you understand that the top times 15 cents, or $0.15, equals the bottom. What about tickets to a concert? Well, how much does a ticket cost? Can you tell? Well, 2 of them cost 70, then how much does 1 of them cost? 35. And then 105 plus 35 is 140. And then 140 plus 35 is 175. So that's how much it costs per dollar. So let's call the top T and the bottom D, or the top T and the bottom C, whatever you want to do. So T times $35 equals D, or X times 35 equals Y, or Y divided by 35 equals X, or however you want to put it. But what's important is that you understand that the top times 35 equals the bottom. And that's all we have right now. I will see you at 10:30.